Hi, you've clicked onto today's tropical tidbit for Friday over here in the Atlantic. What's left of Paula over here. If we zoom in on Paula, we can see where the low-level circulation is over here. Started turning down the coast, came up over here, tried to re-emerge, and is now coming back down. You can see the main energy of the system has gone ahead and escaped out. This stayed together long enough to get north of the Cuban coast, and then finally decoupled fully, lost its convection, got sheared off, and this is now coming down this way. And we can see that it did come further north in the hurricane center track, which was having it get stuck down in the Caribbean over here and then stuck over Cuba. Instead, we see it north of Cuba, passing through the very southernmost Florida Straits on its way out over here, and this will probably be just dying in here now that it's lost its convection, but the main energy went out. And a little farther south than my idea, but farther north than the original hurricane center idea, so kind of a compromise there. And because of its interaction with Cuba, wasn't allowed to stay as strong as it could have been. Maybe it would have lost its convection a little later had it not interacted with Cuba so much, but you did get tropical storm force gusts, moderate to strong tropical storm force gusts in Havana, Cuba, and it's been a bit of a nasty little storm for them. But that's just about it for Paula over here. Looking out ahead now, GFS Day 6 has Richard forming in the Caribbean, and this is what we're watching coming from down here. It'll come from the monsoon trough. You notice how we're starting to get a more active monsoonal circulation near Panama now, and what we're going to have is this trying to get drawn north over here into the Caribbean and try to develop in a hurry once it gets up here. You can see the GFS develops this. This is the 6C run, brings it up near Jamaica, and by day 8 you can see brings it across Cuba and into the Bahamas. If we look at the European ensembles, you can see the center of the variance over here, a little niche of low pressure. This brings it up a little bit farther west. I like this idea better than the 6C GFS, and I'm going to tell you why. One of the things to look at over here is Typhoon Maggie. I'm not sure, I think it's supposed to be a male name, but it's pronounced Maggie over here in the Western Pacific. And the reason I'm showing you this, and a couple of people have mentioned this as well, is that as this comes west, there's a lot of teleconnections that go on in the tropics. When you get typhoons in the Western Pacific, you can often see what's going to happen in the near term down near the eastern United States. If you get a super typhoon coming west over here, it's arguing for strong ridging over here, directing it westward. And when you get that, you usually teleconnect to ridging near the eastern seaboard of the United States, and that's something we need to start watching out for. If you look at the 6C run of the GFS Day 8, here's the storm. You can see the trough to the north over here with enough weakness in here to allow this to get drawn right out. But if we look at the previous run, the 0Z, look at this. You got the trough, but notice where the storm is over Honduras over here. And this is implying enough of a strengthening ridge in here to direct this west before it comes up. And this is something that we're going to have to keep an eye on. Based on the typhoon, which one of these makes sense? You got this and you got this. Which one makes sense? The latter one makes sense because of the ridging. If we go on just the teleconnection, you would argue for this one based on more ridging in here. Now, we can also make some arguments for this. If we look at the upward motion, you notice the dry air sitting in here right now as the SOI burst gives you some upward motion over the Pacific. But notice how we start reversing. Day 5 we see some dry air in the Pacific. Day 10 we see some dry air in the Pacific, and you start seeing green showing up in the Atlantic. And days 10 to 15 you're getting a lot of upward motion showing up in the Atlantic. So if we look at the GFS ensembles day 8, okay, you got your big old trough coming into western Alaska, right? You pump your ridge into the west. Yes, this argues for a trough in the east. It does argue for the trough in the east, but look at the resistance here. Look at the tight jet between here, and look at how high the heights are in here. So let's think about this. If we're out to day 8 and we're starting to get air rising down here in the tropics, what can you say is going to happen to the air over here to the north of the rising air? If you focus upward motion in the tropics, you cause the air to sink to the north of it, and that warms as it compresses and causes ridging in the mid-levels. And you notice the strong heights building in here to resist the trough coming down. You get the strong jet in between, and this is what we should be watching for, is to see this building in here and trying to force something that might come up farther west before getting turned out. And something that comes up into Central America, although it will fiddle around for a while, will eventually get turned out to the northeast, because that's what happens to systems in October. Is it's really hard to get them to come into Central America and then just die out and here cross over, because there are enough troughs. Something will come by, the ridge will build into the east, you'll get some trough to come by and pick it up, and take it out into the Gulf of Mexico. And besides, we got this over here, this trough into the in the subtropical jet stream to the west over here, and what this doing is taking air out this way, and that's ventilating this area right here, the Western Caribbean, and that's more evidence of the building heat in here, upward motion, sinking air, you build the ridge, and you can get storms coming farther west. So this is something we need to watch, where this situation is far more likely than this situation, and you can see the European ensembles are a little farther west with this. The European actually tries to take it into Central America and then sort of on out like this, I believe, in the longer term. So we will continue to watch this. This is going to be a situation that we need to watch very carefully. You can see how the models have been consistently blowing this up, the ones that develop it, and this is something that if we get this going tight, because you can notice a already rather focused area over here in the monsoon trough, we don't have a lot going in the Eastern Pacific. That means that this area doesn't have very much competition. So although monsoonal developments can typically be slow, you bring this up, and if you have a tight organized area of upward motion, you can get a fast developing monsoonal depression, which would be something we don't see all the time. But if you get those to develop quickly, man, it could be something to be worried about. Jamaica, Cuba, Central America, possibly even Florida down the road, we'll have to keep an eye on it carefully. And if we look even farther down the road, just a hint, keep looking, I've been watching the ensembles, and you see all the upward motion starting to show up in here, and then look at how low the pressures have been starting to get in the Central Atlantic and the deep tropics over here. You raise the pressures a little bit in here as Richard clears out somehow, you build the pressures over there, you lower them over here, and might have to watch for one last system trying to come out from the eastern side of the Caribbean, coming in like this, see if we can get some sort of a tropical wave or intertropical convergence zone disturbance to come up out of here in the longer term before the month is out. So we'll have to watch for that as well. Alright, that's it for today. Thanks for watching.